everyone. My name is Tomasz Osiadło and I am Associate Systems Engineer at Cisco. And I'm going to talk about our clustering solution of firewall ASA 5585X. So just to present you the agenda, I'm going to talk about prerequisites, so what is needed in order to deploy the cluster. Cluster advantages, meaning what are the advantages of the technology. What is the cluster when I will be describing how this technology works. And at the end, I will present how well we can scale using our cluster technology. Let's start with the prerequisites from the licensing perspective. Please take in mind that only our 5500X series supports clustering. And I'm going to present you which license is needed on each model. So 5585X will need special cluster license on each unit, and technology can support up to 16 units in the cluster. With ASA 5512X, Security Plus license is required, and we can have up to 2 units in the cluster. All other 5500X units support clustering already with base license, and maximum number of units is 2. It is also important to remember that not every switch can work with ASA cluster, and as of software release 9.3, we are supporting following switches that can work together with cluster. These are Nexus 9300, Nexus 7000, Nexus 5000, Catalyst 6500, Catalyst 3750X. Now I'm going to present what is the main advantage of the cluster technology and why someone may be interested in deploying it. Let's consider scenario without clustering, when more than one unit is deployed for high availability. In such scenario, entire connection table must be replicated across all units. Supposing we have 1 million connections at first unit, and we replicate them to second unit, the total number of existing connections is still 1 million, and solution is not scalable. In order to overcome scalability issues, Cisco introduced cluster technology that is using hashing mechanism, and each unit stores only the part of connection table. I will explain how does it work in the next slides. First of all, I'm going to introduce 3 roles that unit belonging to the cluster can have. First one is the flow owner. For the purpose of symmetry, it is crucial that each packet of the particular connection will pass through the same unit of the cluster. We call this unit the flow owner of that particular connection. Next role is flow director. This is a moment when technology leverages hashing mechanism and we gain advantage compared to replicating entire connection table. Hashing mechanism first creates hashing table that is combination of all possible connections, meaning all possible source destination IP address, sys and ports. Once table is created, it is distributed evenly across all units in the cluster. The unit that stores the status of particular connection is called the flow director of this connection. Now, suppose the packet arrives to particular unit. The unit must determine whether this is a packet of the new connection or of the already existing one. In order to discover it, firewall unit will ask flow director what is the status of this connection. If flow director will respond, it's a new connection, then the unit will become the flow owner. However, otherwise, if connection already exists, unit will become the flow forwarder and will forward the packet to the flow owner. Now I'm going to demonstrate what I was talking about in the example. So we have scenario with a new TCP connection. We have client on the left side and server on the right side, and ASA cluster in the middle. So client is trying to establish new TCP connection, sending TCP SYN packet. When the packet arrives to the unit in the cluster, because of the SYN packet, unit will know that it's a new TCP connection, so it doesn't need to ask the flow director of the status of this connection. It will automatically become the flow owner of this connection. The situation will be different in case of UDP connection. Then the unit would have to ask the flow director if this is a new connection or existing one. So subsequently, after the unit becomes the flow owner, the unit will add the SYN cookie and will pass the packet to the server. SYN cookie is additional improvement when establishing TCP connection, since when returning packet will arrive to different unit in the cluster, the unit can leverage information contained in SYN cookie to discover who was originally the owner of this connection. So again, he will not need to ask the flow director who is the owner, and it will automatically redirect the traffic using cluster controlling to the flow owner, and subsequently the flow owner will pass the packet back to the client. And now, at the end, the flow owner also needs to update the flow director. Hey, I am the new owner of this particular connection. Now I'm going to describe important element of the cluster that is called cluster controlling. As I mentioned before in previous slide, the packets are transmitted via cluster controlling when flow forwarder is redirecting the traffic to the flow owner. It is used also to synchronize the configuration. In the cluster, on configuration is done on the main unit called master, and cluster controlling will synchronize configuration with all slave units. Regarding deployment, there are following recommendations. Cluster controlling is used to transmit data packets during flow forwarding, so it is recommended that it should have the same capacity as data link. Also, for the purpose of redundancy, it is recommended to have two links grouped into port channel. The reason for it is that if the unit loses its cluster control link, it will be removed from the cluster. So let's talk about configuration. I'm going to start how to configure cluster control link. So on each member of the cluster, we need to create cluster group and give it a name. Then under cluster group, we must create cluster interface and determine which interface and which IP address will be used for cluster controlling. Subsequently, we need to determine which unit will be the master. For this purpose, we set priority on each unit. Member with the lowest priority will become the master and of the entire cluster, and all other units will become slave. We described configuration of cluster controlling. Now let's talk about data interface configuration. First thing we need to do is to create a port channel. Under port channel interface, we determined the deployment mode. Recommended mode is span cluster. However, the explanation of different modes is out of the scope of this video. Second thing is to assign statically virtual MAC address. It's the MAC address that will be assigned to entire cluster. And static assignment is recommended as otherwise MAC address will follow the master unit, and if master unit fails, then the MAC address will change. The last thing is to configure virtual IP address as well. Moving right along, I'm going to present most important show commands. Show cluster info con distribution allows us to see what is the traffic distribution across the cluster, so that we can easily detect if there is any asymmetry. And here in the example we can see that unit B has definitely the highest number of connections among all units in the cluster. Another useful show command is show cluster info. Command gives us the opportunity to see which unit in the cluster is master and which one is slave. I would like to talk now about types of failover and how it will impact the entire cluster if failover happens. So first type of failover is when cluster control link fails, and this is the most severe scenario. Failover will cause unit to leave the cluster, and what is very important, unit needs to be re-enabled manually in order to rejoin the cluster. It will not automatically rejoin the cluster. We have also second type of failover when data interface fails. In this scenario, the result will be the same, meaning unit will leave the cluster. However, unlike cluster controlling failover, unit will try to automatically reconnect in 5 minutes, then another attempt in 10 minutes and 20 minutes. At the end, I'm going to present you some data about how well we can scale using ASA clustering technology. So first of all, the throughput. Using cluster technology, throughput scales at 70%. Supposing we have 4 ASAs, each one working at 10 gigabits per second, we will achieve aggregated throughput of 28 gigabits per cluster. In case of the number of concurrent connections, they scale at 60%. So again, considering 4 ASAs, each one having 2 million connections, the total number of connections per cluster will be 4.8 million. At the end of this video, I would like to encourage you to subscribe to our YouTube channel, and I hope this video was informative for you, and I would like to thank you for watching.